Good morning everyone. Day 25 of Adventive Code has started, so let's go. Day 25, Cryostasis. As you approach Santa's ship, your sensors report two important details. First, that you might be too late. The internal temperature is minus 40 degrees. No. Second, that one faint life signature is somewhere on the ship. The airlock is locked with a code. Your best option is to send in a small droid to investigate the situation. You attach the ship to Santa's, break a small hole in the hull, and let the droid run in before you seal it up again. Before your ship starts freezing, you detach your ship and set it to automatically stay within range of Santa's ship. This droid can follow basic instructions and report on its surroundings. You can communicate with it through an encode program running on an ASCII-capable computer. As the droid moves through its environment, it will describe what it encounters. When it says command, you can give it a single instruction terminated with a new line. ASCII code 10. Possible instructions are movement via north, south, east, west. To take an item the droid sees in the environment, use the command take with the name of the item. For example, if the droid reports seeing a red ball, you can pick it up with take red ball. To drop an item the droid is carrying, use the command drop name of item. To get a list of all the items the droid is currently carrying, use the command inv for inventory. Extra spaces or other characters aren't allowed. Instructions must be provided precisely. Santa's ship is a reindeer-class starship. These ships use pressure-sensitive floors to determine the identity of droids and crew members. Standard configuration for these starships is for all droids to weigh exactly the same amount to make them easier to detect. If you need to get past such a sensor, you might be able to reach the correct weight by carrying items from the environment. So this is a cargo optimization problem. Look around the ship and see if you can find the password for the main airlock. So to get the password, hold on a second, we need to get the password, but also we need to have a weight that is exactly the same as a standard droid. I think I might not have understood all of the clues in the instructions, but let's see. Day 25. By the way, oh, I'm saving the page source rather than... Okay, maybe it is correct, yeah. So for everyone else who's working on day 25, the final day of Adventive Code, good luck to all of you. Hey Eric, good morning, and thank you for all of the puzzles if I don't see you again on the chat. Thank you so much, it has been such a joy to do this. And I'm very happy to finish today with the last one. Okay, so I have saved my input and I'm going to make a Python file. Good morning G, Merry Christmas to you too. So dedicated, still up early on Christmas Day. So we can communicate with instructions and it might ask some information. I think that probably, so we're walking around north, south, east and west and such. And we need to pick up items to get the right weight. But then we might also need to go somewhere specific. Let's see if we can find any clue of what exactly we must do. It will describe what it encounters, okay. I think we have to make this interactive. I think so. So let's start with a computer, which is an int code computer from day 9, as usual. I'll turn off debugging mode. And also, what do? We just run it. Let's just run it. Run program. And now I think I should actually get an option to input something right away, but we must provide integers as ASCIIs. So my standard input handler doesn't work with that. So I need to override some kind of input generator, I call it now. Maybe I should change this a little bit. I basically want to have an input provider and not necessarily a generator. So here you see I'm using next on input generator, but it would be easier if I could just call it, you know. So maybe if we don't provide the generator but something else like an input provider that we can just call, then we'll just call it, and in the input provider we'll just say like input from standard in or something. And I'll write also that we are taking input from the console, from input provider. Alright. So that is day 25, and our input provider looks like, hey, where is it? I think I need to define it first so that a PyCharm will recognize it. We'll start by none. So the input provider, is going to be a lambda that takes no arguments and returns input and maps all of the characters to ASCII. So that would be the ASCII code for all characters in the input. And maybe we need to strip new lines? I guess not. Okay. And then we run it. And it doesn't stop. Or actually it stops, but we don't see anything. Because I didn't load any program. A25 input.txt, like that. And now we need to have also an output handler, because the computer will print some data and we should show it also. That's going to be a lambda that takes some input as an argument, and then we'll print maybe I'll just actually make a function that does this. So that gets some values, maybe multiple even, for v in values, do a print with the character that v represents, with no line ending. And the output handler will then be our function. And you see that works, so now we get actually a small story going on. You got in through a hole in the floor here. To keep your ship from also freezing, the hole has been sealed. Doors here lead east, south and west command. Well, let's go east. And now it finished. Okay. Why is that? Maybe we should run it again and try south. Okay, it also finished. Okay. How is that possible? West. And it finished. Okay, let's look at the instructions. We have to provide a single instruction with a new line. And I think our input provider may be not correct. Ah yeah, our input provider should actually I think input generator was actually maybe the right way to go, I'm not sure. So where is it? In day 5 we just changed something. So we have an input provider and we just get input here, but that is a single value. We are expecting a single value instead of multiple values. So we need to be able to call input provider multiple times and then get the last value from the input. So maybe to do that, we can just say that, how can we do that? Input buffer, maybe like this. We just keep the buffer, and we'll make a bigger, like a function where we can actually define variables instead of just a lambda. Oh, and gee, you just made a text adventure a few years ago. Cool, so this is very similar to that. So when our input provider is called, we'll return, if there's something on the input buffer, then we'll return the first item from the input buffer. And otherwise, we'll actually run this one here. So putting all of this onto the input buffer. And we can do that by using the extend function. And then we'll return the first item from the input buffer. So actually we can just do that right after. So if there's nothing in the input buffer, then we'll ask for some input. Okay. So let's try east again. And it took 4 characters, but we should get only 1 character as a value, not a list. So why did it still not work? I think I'm not sure about the input buffer if it has the correct values. So let's break and see. So we go west, and then what? We didn't break. Ah, we didn't break. Maybe the input provider is not working well. Oh yeah, I still use the lambda here. Input provider, so we'll define it like this, and then run it again. Now what happens if we go east? It takes 1 input, okay, and then it should take another input also, but it doesn't. So debug mode goes on, and let's run the computer. Oh, running a lot of things. It takes a long time to visualize. Let's in the meantime look at the instructions. Extra spaces where other characters are not allowed. Must be provided precisely. I think we are quite precise today. And hey Juan Carlos Peso, good morning. Good Christmas to you too. Welcome on the stream. I think we've probably output our questions and instructions at the end or something. I'm not entirely sure. Or maybe it has been output somewhere else. This is Advent of Code indeed. It's the final day. Christmas Day, of course. So what happens? Hey, it's just exiting. Yes, and I'm doing it in Python indeed. Well, what's going on? The debug mode was not very helpful. And so let's say again that... Oh, wait a second, I need to make it false instead of removing that line. You will watch while coding. That's cool. Good luck to you too. So now we're taking input 119 from the input provider. Okay. And then why don't we actually do anything else? Why don't we go somewhere to another state in the Xcode computer where we need more input? That is strange, right? So let's see what happens if we just provide no input provider, because that is a bit of new code. And we'll pass just character 119. Maybe I'll pass all of the characters in the word west. So that would be like over the C for C in west. that is these characters. And if we pass all of those, would it work? Would it run? Oh, I'm passing it to the wrong function. It should be passed to the run program function. Doors here lead. Okay. Just exits. Do we have a bug in our int code computer? That would surprise me very much, because we've actually used it quite so many times in other puzzles. It will describe what it encounters when it says command. You can give it a single instruction, terminate it with a new line. Oh wait, I have to pass a new line character. Ah, but wait, doesn't input also return a new line character? Like, hello, enter. Oh, input strips the new line character. Man, that is something I did not expect. I think in Python 2 there might have been a new line character, but I'm not sure. So we need to extend it with all of the items in input plus a new line. Wow. That was a simple bug, but a bug nonetheless, and an important one. So if we go east, we still stop, apparently. Maybe that is because I should kind of concatenate them before looping over them. So east, A, it still didn't work. So we're popping the first item from the input buffer every time input provider is called. And I want to print the input buffer every time. East. Okay. And then we'll just add a character like 10 for new line. Let's just do that. Okay, now it seems like the 10 is added, but the computer doesn't take multiple values or something. So when we had self.inputs, that worked, but when we use the input provider, then it doesn't work. And why is that? Oh, maybe I should use elif or something like that. Oh yeah, because we're no longer waiting for input if we did have an input, right? Yeah. But I'm still not sure why we didn't see waiting for input. Ah, because debug was not on. So, okay, I see that I didn't kind of break off my cases correctly. So east now works, right. Yeah, now we take all of those inputs. Okay. If self.debug, then we can print this statement, and otherwise let's not do that. And the input buffer debug statement is also no longer needed. So now we have a nice clean game interface. So we go east. Storage. The boxes just contain more boxes recursively. Doors here lead west. What was the bug? The bug was totally in my code. I just added a new piece of code that handled getting input from a function rather than a generator. And I had to make sure that if I got input from that my other input handling logic was not going to be executed. And after that, it ran correctly. Yeah. Every line of code can introduce a new bug, and sometimes two, so I should really remember not to add too much code. So, where we go now? West maybe? That's the only way, right? Doors here lead. Okay, this is going to be confusing very soon. So I'm just going either east or west as soon as I can. You got in through a hole in the floor here. Your ship The hole has been sealed. But I think that is just the place where I started, no? East and then west again. Yeah. I've never played text adventure, so I might be very stupid going left and right without realizing it. So maybe what we can do is actually print something. Maybe we can parse these texts and then make a map or something. Or maybe I'll just draw a map here in ASCII art, because I do need to see my code and the drawing at the same time, so I cannot really use my whiteboard. Or, well, maybe I can. But this is also a fun way to do it. So let's say that we start here, and when we run it, we go east, and then it says it contains boxes recursively. I don't know what that means, but here we can only go to the right. So we go west, and can we do inv? I don't have any items, so let's go south then. And items in here, photons. Okay, maybe we should pick them up. Take photons. It is suddenly completely dark. You're eaten by a grue. Don't know what a grue is. Okay, so we should not take that, I guess. I suppose. Oh, we exited also. We're completely done. Okay, so maybe let's not go there. I'll mark an X. So we can go south, but we shouldn't actually take anything. So I'll mark that as a trap. A trap is a tilde. Alright, so we can go east. Let's go to the... Hold on. Didn't I go east the first time? And east is actually on the right. Oops. But that was a recursive box place thingy. And when we go south, we get photons, and then we go, let's say, east again. Someone seems to have left it on the giant grid setting. Holodeck. Items here, mutex. Okay, take mutex. We take the mutex. Inventory. Okay. And how about our weight? You get a list of all of the items. Okay. But we need to get the password. How does the password actually work? I think that the robot will just output the password once it finds it. And what is our mission, in fact? Our mission is to weigh the same as a droid, I guess. And we are, but are we a droid? Yeah, we are a droid. So we shouldn't pick up anything. Is it true? The airlock is locked with a code. The best option is to send in a small droid to investigate the situation. You attach your ship to Santa's, get in, and okay. It follows instructions, it describes what it encounters. Okay. The ships use pressure-sensitive floors to determine the identity of droids and crew members. And all the droids weigh the same. Okay. If you need to get past such a sensor, you might be able to reach the correct weight by carrying items from the environment. So I should weigh as much as a crew member, I guess. I'm not sure exactly. But we also need to find the location of wherever that sensor is. So where are we? Can we get help? No, we can't. So we are in the bottom and we can go east, south and west. Let's go to the west. Gift wrapping center. How else do you wrap presents on the go? Here are photons. Let's not pick them up. So we go north. Let's go north. Wait a second. I said west and I didn't go right. I went left because west is left. So now I'm back at the start basically. Okay. Yeah. So then I need to go back to the bottom right, so I need to go east, east again, and I can't go that way, so this is blocked. I'll make it a hash as a wall. Okay, so we go south and then, hold on a second. You know what, I'm going to restart it. I'm not sure where I am right now. So we can go east and then we can go south, right? And then we can, oh, we cannot go south. And what was this M here? I'm not sure now. Okay. Yeah, from the right we can only go left again, that is true. I think that my drawing is not very helpful here, because you cannot see where there are walls. So I'm going to use my drawing board, and I need to put it on the right side of the screen. Maybe here. Let's keep some space for the browser also. Alright. And then we don't have a lot of space for this, so maybe should just go like this. Takes a bit of fiddling. And you see some icons on my desktop. Oh, well, that's fine. Alright, so our grid looks like this. I have no idea how many steps we're going to have to explore, you know, it might be very much and we might have to write an AI to do it. So the starting position is here marked as an S. And I think it might not be clear enough to read, so let's increase the size a little bit. Like that. And so the only place we've tried so far is to go east, and there you cannot go anywhere else, so I'll mark there a wall. Maybe like this. And then we go west again to go back, and then we want to go south. And from south I can go north, east and west, so I can go north, east and west, and not here. There are photons here that I don't want to pick up. E for photons. So let's go to east then. And here is a mutex, and I'm not sure what to do with it, but let's remember it. And what else? Then we go, where can we go from here? We can go east, south and west, so we can go, I drew a door there, but there is no wall. We can go east, south and west, yes. Let's go east again. And here we can go east, south and west. But on the top is a wall. Need a little bit more walls here. A bit more walls on the grid. Yeah, probably this is going to take a long time to do by hand, but for now I'm just curious to see what we encounter on this adventure and how it works. So I've marked where we can go, so we can go south and there's ice cream. Let's take the astronaut ice cream. Just for fun. Okay. Let's go east again. Reindeer-sized stables, they are all empty. Okay. We can go east or west only from here. Oh, here's a wall. Then let's keep going east. The metal walls and the metal floor are slightly different colors, or are they? And here we can go only to the left. And infinite loop, I don't think that is something we should actually pick up, but let's see what happens. Infinite loop. Oh wait, I think I mistyped that. That's funny. Okay, I could have expect that, of course. Okay, so we go south, east, east, east until we reach an infinite loop, and then we go west again to go back. Oh, this was an infinite loop that we don't pick up. Oops. And then, so we're now back here. And where do we go? We go... Oh, we cannot go anywhere. We can only go west. And then from here we can go south. There is a tambourine here. And we can only go north. So there's just an item to pick up. Tambourine. And wait a second, the ice cream. I do want to remember that there was an ice cream. Like this. Okay. Then we can go east and south. Oh, wait a second. The tambourine. Oh, we need to first go north. And then go west. Yeah, that's where the mutex was. Okay, now let's go south. And there's an escape pod here. I wouldn't think that we need to have an escape pod. Escape pod. And where else can we go from there? We can go north, east and south. Go north, east and south. Hey, we can go east? That is confusing. I thought we couldn't go east. Oh, I think I mixed up some locations because I think... Let's try again. I think when I went first south, and then I see that one of us, Valukadari, has solved already the first part. So that was a fun adventure, I hope. And unfortunately I didn't hear any alert going on, but we did see a star. So maybe my alert code is not working very well again, unfortunately. So I was just confused a second. I went south and then I went east and then I went east and then south. Then we should end up with T. What was T? Tambourine, right? And then from there we can only go north. Okay, so if we go north and then west again and then south, why can we go east? So I think that when we see walls, we cannot assume that they are kind of impenetrable from both sides. So we cannot go to the left from here, but we can actually go to the right from there. And then we find out that if we go to the right from there, so that means east, from the escape pod we can go north, east and south. So we can also go south. Let me draw that. There's a way here. When we go east, we find that we are at a mug, a place with a mug. So that is strange. So this is not a kind of Euclidean space. This is something different. I'm not sure if that is a bug in the puzzle, or probably not, or that the spaceship is just very weird. And we have doors, and maybe the doors have hallways in between them, so that when you go to a certain space, you first walk the hallway into a new room. And it doesn't necessarily have to be a grid like this. So if we go to the east, then we end up in some kind of room where we find a mug. You like how the options are hallways or non-Euclidean space? I don't know what other options are there. Maybe hallways are more simple. Occam's razor. Simplest solution. So here we can go east and left, so that is like east and left. East and west, and there was a mug. Okay. Let's go east then. I just want to keep going east. Sick bay. And we can only go left from there. So there's a wall. and we cannot pick up anything. Okay, so now we've explored that part, and we can go west again to end up at the mug, and then west again. Then we're at the escape pod, and then we can go south. You see evidence here of a prototype polymer design work. Doors here lead to either north, east, or west. So like this, not south. And items here, molten lava. I guess I'm not gonna pick that up. And I think this is also an indication that we cannot just pick up anything. So we can make an AI that would just try out picking up an item, and then if it dies, just, you know, don't pick it up anymore. Maybe that's the way to do it. Or we have to actually play the game by hand. So we are now at molten lava, and that is a kind of bad thing. We should not pick it up. Let me mark it with a small purple X. The infinite loop I'll also mark with a small purple X. And let's go east again. There are a few telescopes, they are all bolted down though. Doors here lead west. Okay. So I'm still kind of drawing these walls because that seems an easy way to do it, but it is actually not correct. So we go west, and then we can go still west, and we see a giant electromagnet. Can we pick it up? I think actually we are probably going to die because we are a droid after all. And it cannot handle electricity very well. No, we can. Oh, inv. Oh no, the giant electromagnet is stuck to you. You can't move. But can we drop it? I guess not. Nope. Okay. Well, that's okay. Then we'll just restart. How about that, huh? Okay, so that is the electromagnet, and don't pick that up. We'll go south and east. So I'm really learning east and west now from whether they're left or right. I'm very practicing very well. So we go west. Might as well try all the items. Yeah, I did try it. Oh, I didn't try the escape pod. Maybe I should. Let's go north. Oh, let's go east and then north. And let's take the escape pod. Okay, yeah, I see. I think you just want to let me walk in all of the traps, don't you, Eric? So the escape pod is actually bad. Yeah, correct. Okay, so we restarted and we go south, east, south, south. Then we go to the west, which is left. And there's a giant electromagnet, and we don't want to eat that one. We can go east or south. You better try the molten lava. Yeah, I'm sure that will give us something fun. East and south. Well, I guess when you're making all of these puzzles, you really want to see people's reactions to every single one of them. Well, we might try it out later. I'm first going to try to get to the end of part 1. So we are going south. Now I noticed that actually I should make a note of what was actually there, because if I don't, then I'll forget about where I might be. So there is the magnet. And I went south from there, and then I find an Easter egg. Okay, take Easter egg. Chocolate, please. Okay, cool. I guess nothing happened, I suppose. Egg. And we can go from there. Oh, I noticed that when I zoom, you also see that I'm zooming. Yeah, I guess that is fine. Okay. And now we are at the egg, and we can go north and west. So we'll go west. A pressure sensitive floor will verify your identity. Okay, maybe we've reached it. So let me mark that one. And we can go east and west. Oh wait, in the next room. Ah, okay. So the room with the floor is actually here. And here is nothing. Here's just a kind of a warning about it. So let's go to the west. A loud robotic voice says, "Alert, droids on this ship are heavier than the detected value and you are ejected back to the checkpoint." Okay, but what is in our inventory? Only an Easter egg, so the Easter egg is too heavy. But wait a second, I am a droid, right? So I should just drop the Easter egg and then go west again. And now... oh. Oh wait, I am still heavier, but I have nothing. I'm not carrying any items, and I want to go on the floor. Oh, droids on this ship are heavier than the detected value, so I'm too light. I am. Exactly, thanks for that mistakes. So let's pick up everything that we found so far. Let's go to the... oh, you know what would be cool if I could actually handle... yeah, that would be cool. If I would use my input to detect what I'm writing and then kind of make a map of where I'm going. So that is just a little bit of extra. So this would be the command. Why can I not extract that into a variable? Well, okay. So our command is like this. And then depending on the command we go up, left, right or down. So if command is north, our X position is, no, our Y position is going to go up. So we have an X and a Y. Wait a second, X, Y is 0, 0. If command is south, our Y is going to go down. Oops. And if command is west, X is -1. If command equals... why do I get highlights everywhere? Maybe I need to make them global? Yeah. East, then we go to the right. And maybe I actually wanna overwrite my command so that if I say, let's say L or R, that it would make it east and west, because I tend to mix them up. So we have some aliases where I can use L for west and R for east, and up for north and down for south, so that if our command is in the aliases, then I'm going to take the command from the aliases. Ha! Cheating here. So we have a grid of where we are, and not sure how it helps if we don't know the walls, but maybe. So items here, that is a kind of list, right? So maybe we can keep track of that when we have output. So we have an output handler here that gets some values. Not so sure yet. Maybe I'll just say where we are, just for fun. Going somewhere. Location is now XY. Okay. So we need to pick up a lot of items, right? We can still go up. No, we actually have a starting point from which we can go east, south and west. And I haven't marked that on the map. We can go east, south and west. And when we go to the west, what do we get there? We get nothing. Why is that? Nothing seems to happen. If not input buffer, we have a command, we have input. Did I just break my code? I don't think I did anything really. We are also appending the 10 here. Maybe I should turn on debug mode. Or the alias is causing a problem. Okay, this runs for a long time and we see characters coming up. The last time this happened was when I actually didn't provide a new line character in the end. So let's say we go east, or no, I should, well, maybe I can do it. A lot of things happen. Because I should have written east instead of E. That takes a bit of time. So how's everyone else doing? Are you all playing the game right now? And Reboot Tech, you're joining us with a party of 6. Thanks for that. I hope everyone is having fun. And you finished a few minutes ago. Okay, cool. So you just played it by hand, I suppose. And Eric, of course, is already done. We know that. So I'm gonna go west here and see what happens. And we do take input, but we don't take more than one character of input. So I think something is going wrong. Maybe this command in aliases is not working. Let's see what is in our or how does it work when we have aliases like this. We should be able to just do like, hey, copying this, pasting that. And so is L in aliases? We get true, right? Yeah. Failed sleep. Highlighting what Reboot Tech is saying. Non-existent emote read. And we're all very excited about something and I'm not quite aware what it is. Okay, you know what? I'm going to remove this part. Oh, I know why. Maybe I'm taking a command always instead of only when I have nothing in my input buffer. Maybe this is the problem. Yeah. It should be like this, right? Yeah. Otherwise, I'm just calling input all the time. How come none of you have noticed this, huh? How come? Am I only by myself here? So I'm going to the west to see what is there. And we're stranded. Please supply measurements from 50 stars to recalibrate. No way, I don't have 50 stars. I only have like 48 or something. Or 46. Okay, so world peas are there. Peas. Okay, let's pick them up. Take world peas. And then we go to the east again, which means right. Yeah. Okay. We can now go only. Oh, I think we've explored all the areas actually. No, wait a second. Those peas were actually not in the south. They were just a little bit up. They were here. But that means we can still go south and then we can go east, which is left. And that was a bowl of rice. Okay, so let's take the bowl of rice. And from there we can go north and east. So there's a kind of way to go north here, which probably goes up around it. So there are closets. Oh. 2018 had closets in the beginning, many closets. Oh, I don't know about that. At least I don't remember that. So from the rice we go up, and I think, yeah, we don't actually end up in some place that we don't end up at the piece, which you might expect. So there's nothing there, and we just kind of have to go back. Go down, and now we're back at rice, and we can go right, and then we are at the photons, and that is all. So now we've explored all of the territory. So let's see what we have. We have bowl of rice and world peace. World peace. That is funny. World peace. Nice. Let's also take the ice cream. So we go right where the mutex is, and then go to the ice cream. Astronaut ice cream. And I made a note of tea, but I'm not sure what that one was. It's a tambourine. Let's take that one. Tambourine. And then we cannot go left. No, but we can go up, left, and then down, and then left and down. Take the egg also. Anagon Live, now that the leaderboard is full, I can tell you the real reason why you're experiencing non-Euclidean shenanigans if you want. Oh, so people have already solved it? Oh man. Let me have a look. Leaderboard. Oh wait, how do we know this? We have to go to stats and see that more than 200 people have gotten the score. Yeah, tell me, why is there non-Euclidean space here? I am a bit surprised about that. So we take the Easter egg, and now we can go left and then try left again. Droids on this ship are lighter. Okay, the rooms aren't squares. Oh god, is that the reason? Well, that's basically the same as having hallways. Well, I think you could probably model it in the same way. But yeah, we have no way of figuring out the length of halls except for trying to find an alternative consistent configuration where we don't jump over rooms as we're doing here. That is of course something that could happen, yeah. Huh. The rooms are not square. Okay, so we are now too heavy. Basically what we can do now is drop every other item and see if one of them helps us get through the door. And what I want to do is I want to kind of figure out the weight of all the items. So let's check our inventory. So when we do, we have ball, Easter egg, tambourine, astronaut, and world peace. And then that single line makes it all make sense. Ah, yeah. That the rooms aren't square, right? Okay, so this is too heavy. Let's try all the permutations. Let's do that. So we use Python to figure this out. So we import iter tools, which I think I imported before. IT? Yes. So permutations of beta, that gives us a list like this. Wait a second, permutations is just all the different orders. We don't want that, we want to have all the different subsets of it. How do you do that in Python? Does anyone know? All subsets. Yeah, combinations, that is it. Beta, and we need to provide an argument, which is how many, and length subsequences. Well, no, I don't. I want to have all the subsets with not exactly any number of elements. Well, maybe then, if that is really so hard, then we'll do all the combinations with 1 plus all the combinations with 2, and all the combinations. That doesn't fit. Plus all of them with 3 and all of them with 4. And then we cannot add it because we need to make lists of all of that. Well, I would love to know an alternative to this. I want to have all the combinations of items that we can try, and like this. Let's see if that works. Syntax error, because I'm not using a Python scratch file, I don't get a highlight for that. Oh, I think I lost some of my input here. Is it now correct? Yeah. So here are all the possible combinations, and let's just try all of them. Like this, and let's make them nicely aligned. So all the closing parentheses. Oops. Those are going to get new lines, like this. So we're going to try out all of these. Those are 31 options, and probably once we're too heavy we can rule out a lot of them. So we are here in our console, and let's try the first one with, maybe let's start from the end. That would be the easiest. So we're going to try 33, which has the egg, the tambourine, the astronaut ice cream, and the world peace. So it has no ball of rice. Oh man, that takes a long time to figure out. Drop ball of rice, and then we go left, and it's still too heavy. And then what? So we pick up the ball of, maybe we should just drop something. Let's drop also the E, the Easter egg. And we go left. I'm not sure. Oh yeah, here is actually the output. And we're still too heavy. So, okay. Let's drop another item. We have still left a tambourine and astronaut ice cream. Let's drop the tambourine. And let's go left, and we are still too heavy. So we drop, now we have only astronaut ice cream and world peace. That is this one. Too heavy still. Maybe ice cream is too heavy. This, and let's go left. And we're still too heavy. That is surprising. And all we have is world peace. So world peace is just too heavy actually. So we should not have world peace with us at all. So everywhere where I find a W in my list of options, I'm going to remove that line. That's a lot of them. So now we have a bunch of other options to try. Let's try B, E, T, and A. So we have in our inventory world peace. Let's drop them. And let's try the ball of rice. And let's go left, and we see we're too light. So that is like that, and we can add to that E, maybe Easter egg. Take Easter egg and go left. And then we are too light still. So Easter egg and B is still too light. And then what can we take? We can take a tambourine. And we go left. And then we're too heavy. So when we have B, E, and T, then we're too heavy. So one of those three makes us too heavy, and it's not so clear which one. I'm guessing that the tambourine might be too heavy. So let's drop something else and see if the tambourine is the bottleneck. So we have Wait, what do we have now? We have a bowl of rice. Wow, 50 stars. That is amazing. Wait, wow, all of them. So we have a bowl of rice. Let's drop the bowl of rice and go left. So that means that we now have an Easter egg and a tambourine here. And it says that we are still too heavy. So that is with while having an Easter egg and a tambourine. So I guess the tambourine is just too heavy in general. So let's drop the Easter egg. I hope that is going to work now. Drop Easter egg. And then we'll go left. Oh, you like the background when you get the 50 stars. Oh, now I'm very much looking forward to it. And I'm not gonna get 50 stars after solving this puzzle. Okay, so what are we doing now? We have heard that we are still too heavy, and that is because we have only a tambourine. So that was indeed correct. Let's not use tambourines at all then. So we have only a few options left. Now I do wanna try only an Easter egg and see what would happen with the Easter egg. So take Easter egg, and then let's go left, and then we're still too heavy. So actually Easter egg is also not a good one. And I now realize that if some items are really heavier than the minimum, or like than the maximum, then you should try single items first, so that you can roll them out as quickly as possible. So all of the Easter eggs are now out. So we have only a few options left, which is A, just only A. That was the astronaut ice cream. And then we go left. And we are too light. So that means that the only last option is B, which is the bowl of rice. Drop astronaut ice cream with a space. And we take the bowl of rice and we go left. No. All droids are in the ship are heavier than the detected value. Oh no, I have to also take the... I have to take... Wait a second, what did I do? Ah, okay, I have to take both of them. Oops. Take astronaut ice cream. And then go left. Wait a second. I think I probably mixed up lighter and heavier at some point, unfortunately. You have so many foods as your items. Oh, so that might have been kind of random. Okay. So I feel like now maybe writing a little bit of an AI that tries everything. I'm not entirely sure. Yeah, we can do that. Wouldn't be too hard now, would it? Basically, when we are doing an input, if we provide it first with all the inputs to go to pick up all those items, I'm not sure. Oh, well. I think I made a mistake, so I have to try it again. I'm going to remove all of the hashes here. And just try again. And at the end of the lines, I need to remove all these notes that are no longer correct. Like this. So first let's start by trying out all of the items separately. So when we have dropped the bowl of rice and we go left, then it says droids are heavier, so that means that with this we are too light. Yes? Now we drop it and we take the Easter egg and we go left, and we are still too light with only the Easter egg. Okay, we drop the Easter egg and we take the tambourine. Then we go left, and then all droids are heavier, so we are still too light. Drop the tambourine. Then... oh, I know what I can do. I can actually pass this whole list as input to the droid. Basically like take B, go left, drop B, go left, and so on. So that is what I'll do. And so first I need to provide it input for reaching to go to all the right locations. So the inputs is going to be a huge array, which I'm going to have to convert into characters. Oh yeah, I can just write a big string, and that one will be mapped to like this, ORDC4CIN, like this. So how did we go to the right location? We did it by, give us a little bit more space. So we did it by going first west, take the piece, world piece, then go east again, and then go south and go west, and then take the bowl of rice, then go east, take astronaut ice cream, then we go west again, then we go south and west and south, and then take Easter egg. And now we're missing one item, the tambourine. Yeah, okay, so after we take the ice cream, we should go south and take the tambourine, and then go north, and then go... then we're at the ice cream again, and then the rest should work the same as before. Alright, so now we've picked up all the items, right? Let's just run this code and see if we are ending up in the right place. Oh. Hallway. This area has been optimized for something. And we can go north and east. Wait, where did we end up? Gift wrapping center. We are at the photons. I think I went after going to the tambourine and taking the ice cream. I shouldn't... oh yeah, I should go there. And then... after taking the ice cream, I should go west and south, right? Let's see how we go. So we have taken the items from the start. We take the world piece, and then where do we go? We don't see that actually. It's not so clear. Maybe here. When we actually pop something from the buffer, let's print it. So that is a character like this, and then we'll print the character with no line ending so that we actually see what we're passing to the computer. Mr. 380, you give up? People have already solved and you've made zero progress. Sucks to be stupid. Hey man, you talk to yourself like that, you're never gonna solve it. Don't give up. And what are you stuck on actually? Are you playing the game as I'm doing? Did you make a map? Making a map helps very much. And also, yeah, don't conclude that you're not smart when it doesn't work, you know? We all get stuck, and the way to overcome it is just to try different ways. Or maybe take a break and try again later. So, what did I just do? I was making sure that every time I pass an input to the computer, I'm printing something. And I'm not sure if we can actually see it. So I want to say that I'm going somewhere. No, wait a second. This is only when I'm actually writing input by hand. And when I'm passing input from a big list, it doesn't really... we cannot see that it's taking that, so I cannot really debug it easily. Unless, of course, I would do something here. Like maybe I will just print everything. No, it's when I'm taking here from the normal input array. Like if I don't have inputs, so if I do have inputs, that is when. So if we have input, then we're actually going to print it. Yeah, like that. Print input with no line ending. But we're going to get character codes, so that also doesn't help. Maybe I should start by filling my input buffer with this instead of passing it to the inputs. So we have an input buffer like this, and that is going to contain all of that. And then I could do my little trick here, where if I'm popping anything, then I'm going to show it. So C is the input buffer, and I'm popping on the left, and return that thing, and also print C without a line ending, or whatever, with a line ending, also fine. Oh, okay, as characters, yeah. This maybe okay, maybe with a line ending, without a line ending, I mean. Okay, now we can actually see it very clearly, and just for fun, I thought maybe we can highlight it, but no, we can't. Okay, just like that. So we went from the hull breach, we went west, which is here. We take the world peace, and then we go east, and then we're back in the hull breach. And then where do we go? We go west again, but we should go south and then west, right? So after... Oh, we went south, and then we went west, and we take the rice, I hope. Yeah, take ball of rice. And then we go back east. We're back at the wrapping center where the photons are. Then we go east, and there's no... we have to go east once more. So east, east, east 3 times. That was the problem. So are we then now at the Easter egg, and now we can go to the west, so we're on the pressure plate. Judging by the Twitch private leaderboard, it took smart people minutes and not months. Yes, some people are very fast, some people are less fast, and that's fine. We have different experiences. Some people have worked on these kind of problems for many years. Some people have it as a hobby and they train themselves to do it. Sometimes we just need to work on our skills to be faster. So the way to learn is never to judge when it doesn't go as you're expecting. Alright, security checkpoint. So now we're just before the sensitive room and we can try to go somewhere, right? Alright, okay. Let's see how we're going to go from this list into something that would try out everything. So these are all of our combinations, and I'm going to write them here somewhere. Combinations equals this one, and they are tuples, which is fine. Like this. And what I want to do when I try a combination is basically what I want to do. Yeah, I'm going to append all of these options to the input buffer. So maybe I'll call it program, like this, program equals this thing, and then we're going to try out all combinations. Right, Alright, let's go over all of them. For each combination in combinations, we're going to say that we take each of them. For each item in the combination, we're gonna say that we are appending to the program an instruction to take that item, like this, with a new line in the end. And the item is, of course, not A, B, C, and D and stuff. So we have an items dictionary that contains world peace. So W for world peace, and ball of rice like this. So we're just mapping it. A for astronaut ice cream. Astronaut ice cream. Spelling is the biggest challenge here. T for tambourine. And E for Easter egg. Problem solving is problem solving. You either can or can't. I'm not saying that stupid is final destination with nowhere to go. I'm saying I'm there. I recommend you read the book Talent is Overrated. That might help you get out of this mindset. There's also a book about growth mindset. I'm not sure what it's called. Mindset. So there are different mindsets that you can have, and people have either a fixed mindset or a growth mindset. And fixed means that you think that the way you are is just the way you are and it won't change. And growth mindset means that you believe that in some particular area you feel like you are able to grow and to improve. And now what tends to be the case is that people have a growth mindset in very specific areas where they feel like they're good at it because they believe that they have a talent, for example. And in other areas they believe that they don't have a talent, and then they will have the fixed mindset. And that will lead you to not try things, to not learn, to kind of reject any attempt of improving it. And that means that you will also not improve. So actually it's a self-fulfilling prophecy. And so one kind of general advice and philosophy that is recommended is to consider always to keep a growth mindset. Because the truth is that your brain is flexible and actually it's not fixed. So even though you might have certain structures in your brain and patterns that make you not good at something, for example, let's say I'm not good at soccer, but also I don't ever do soccer, so it makes sense that I'm not good at it. But just because your brain doesn't have the patterns learned to be good at it doesn't mean that it can't, you know. Your brain is still a brain that is a giant crazy neural network that can just recognize patterns, and all you need is just to kind of take it easy and don't pressure yourself, because your brain learns when you get positive feedback, and if you give yourself negative feedback too much, then yeah, your brain is not gonna be able to pick up all of the patterns that it needs to learn. So that's my personal advice to you, or for other people who are feeling like they're stuck or Advent of Code is not for them. And G, you're saying Advent of Code really helps you to overcome that. Yeah, I feel the same way. I felt that last year quite daunted by all of the puzzles, and I was not able to, well, I might have been able, but I felt like it took me so much effort, and I thought, no way, I'm not gonna be able to finish this. And that's when you give up, right? And this year I'm really trying hard, and also I'm on the stream, of course, so that puts a little bit of peer pressure on me, or just a little bit of a feeling like, no, I'm not doing this only for myself. Other people might enjoy me trying to solve the problems. And so this year I find out that I'm able to do so much more than I expected. So yeah, don't give up. That's my message for you. We're gonna try all the combinations, and we've just made a map of all of the letters that I put here in this huge list. And so we're gonna look up the actual names. So from the items we'll take the letter and say that we take that. and that is what we're appending to the program. And then we have to go left afterwards. So that would look like this, which is west, yeah, with a new line. And then if it didn't work, we suppose it didn't work, we're gonna go east again. And that's it. We keep doing that. Mistakes, what are you saying? My only worry is that some people failed on day 7, I think that was the first concurrent one, and figured that they couldn't get a working interpreter, so there was no point in continuing on. Hopefully that didn't happen much. Well, let's see if day 7 is actually a drop-off point for a lot of people. We can see that. So 7, it has a little bit less completions than 6, but we see that day 8 actually has more people going. It's a bit hard to say. It looks like actually the biggest drop-off is at 5. That is the first Encode computer, I think. No, it's the second addition to the Encode program. Alright. And yeah, if you need to go, of course, do whatever you need to do and look at the YouTube video later online. See that we're getting a lot of more audience, that's fun. I was actually expecting that no one would be here today, because today is Christmas and all, but we're still here. So apparently we're now in a kitchen. Oh, hold on. It was the very last option that was actually the right one. Can you believe that? Was that the case? So ETAW, but I think I tried it. Let's also print, just before we go, what we had in our inventory. So we have inf, just to have a look. And then we go west, right? Well, let's run it again. So we're trying everything. So security checkpoint, and we say we go east right away. But so we have everything, and then we say we go west. Wait a second, no way. Don't forget you need to drop your items to clear things. Oh, I didn't do that. Oh, but the funny thing is, I only took my items and then I went left, and actually it turns out that you need all your items, but that makes no sense. So here you see that I have all my items and I'm going left, and it says, oh, I think I'm actually one position too early. But no, I'm just one position too early. So let's run it without taking all these items and see where we end up. So where we end up now is in the next room. A pressure sensitive floor will verify your identity, and if I would go west here, then we're going to be rejected, right? So why is it then that if I take my item, check my inventory, then go, and then, oh, we don't have to do east. That is it. We don't have to do east, because if we're rejected, we're already going to end up back on the tile where we can prepare. So we take it, we go west, and then we're going to drop all of our stuff. And also we don't want to go west for every item, we just want to go after taking all of the items. So like that. And then we're going to drop all of our items. Drop S with a new line. And we're going to drop the item like this, so that we have nothing in the end. So this is going to take a bit of time. And now we need to look here wherever we don't get a loud robotic voice. Man. Okay. Maybe whenever I say that we're going west, that is when we get a result. You've really typed everything. Wow, okay. West. No, that's not the right command to search for. Pressure sensitive floor analyzing. Ah yeah, so when we see analyzing, that's where we're actually going to be checked. So the first time is here, and it's bad, 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 bad. Not good, not good, not good, not good. Let's just keep going until we see anything else than an alert. That was the end. Maybe we don't get the word analyzing in case it works. Do we actually go on with the right inventory? So we drop the piece and everything. Try dropping all of your items when you enter the room before you start. Maybe that's a good idea indeed. But I am dropping every item after I took it. So that should also work, right? I can drop all of the items, yes. So let's do that. But you're holding everything during my first combination check, is that true? So we're at analyzing and we're going east, and at that point I have everything. That is indeed a bit strange. Ah yeah, because I pick up all of the items and then, yeah, now I get it. So actually the first attempt that we're trying is not right. Yeah. Thanks for that. Very good help. So let's take all of the items and drop them before as well. Yeah, that's something I didn't realize. Okay. So it's going. And let's look at where we say analyzing. And the first is here. And we still get alerts everywhere. Alert, 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 alert. Okay, a lot of alerts. And it says that we're still lighter, even though at the end we have tried like 4. And now we're at the very end. Oh wait, so it means we're too heavy. When you solve it, the program won't accept any new input. So, okay. Maybe I should just search for pressure sensitive floor instead. Like this. Alright. Well, I'm just going through all of the places where I'm on a sensitive floor. Is it possible you haven't found all of the items? Your game had more items than 5. Ah, I think I do. I think I've went everywhere. I've been everywhere. But maybe I haven't. Or just drop your items and run your combinations again. Why? Why would I do that? Okay, that's it. And let me just actually check what I'm doing. So whenever I go on the board, here you can see. Wait a second, am I dropping before I actually go west? No, I'm dropping and then I'm taking items, right? Yeah, I didn't start. Yeah, but so I solved that issue by going over all of the items, the actual full list of items, and dropping all of them. And, well, I could do it like this, just so that before I end up with nothing, or I start with nothing. But it's basically kind of the same. Let's run it again. And it doesn't remember my search. The first time we enter the sensitive plate is here, and we have only a bowl of rice, okay? Yeah, so I added that already. Everyone has the same number of items. That is a nice hint, so that means I missed one item. Maybe I should pick up the lava. Let's see. Maybe, okay, so I'll run it until the very end. And that means that I have now nothing in my inventory, right? And I am here at the exclamation mark. And let's go then right. Everything here is freeze-dried, but there's nothing there. So we go up, and we can go east and south. That looks like in my map. And I cannot pick up that one. I can go right. Here's molten lava. Okay, why the hell not? Let's pick it up. Take molten lava. You melt. Okay, that's what I was expecting. So there you go, Eric. I tried it. Now we are at the exclamation mark and go right and up and right. Here was molten lava. Oh. Yeah, that's the after the magnet. Okay, and then we go right, and there's nothing there. So we go left again, and we could only go west, yeah? So now we have molten lava, and we can go up. So we're here, and we have an escape pod. We cannot pick it up. We can go north, east, and south. And when we go east, we... Oh, hold on, right? There's a mug. Ah, I can pick up the mug. I forgot about that. So, after we take the astronaut ice cream, we go south, take the tambourine, and then we go back up and left and down. Then at that point we can actually go east and take the mug, and then go west again. Yeah. So now I want to have my list of combinations that has also a mug in it, which is an M. And I have to add it here. That means that there's another kind of combination with 5 items that I should check. So plus the list of combinations with 4 and then with 5 also, right? That is our new list. That is going to be stored here. Okay, so how did you ever try all of those combinations, G? Or other people who have solved it by hand? That is like impossible. That is like 5 times 4 times 3 times 2. That's 120 combinations. No way you tried all of those. There are better algorithms than blindly trying everything. Yeah, I tried that before. That was eliminating first which items are too heavy in general. But it didn't work because apparently I forgot about the mug. Okay. So we're dropping all of the items, but let's drop only the items in the combinations. So we don't get these weird errors. Oh yeah, it's not about the order, right? Yeah, okay. So we don't have... We have 120 different orders, but that's not what matters. Yeah. Actually, I forgot how to calculate that. You're saying 2 to the power of n. But I'm not sure why that is correct. I remember you have like... 5... 1 out of... 6 plus 2 out of 6 plus 3 out of 6, something like that. Okay, let's look again at the security checkpoint. Pressure sensitive floor. Now we have a lot of results, of course. How many results do we have? Can we see that? We cannot see that. What is this checked? Select all occurrences. Okay, interesting. Okay. Alert, 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 alert. We just keep going like this. Well, well, well. There we go. I just hope that once we reach the other side of the security door, that we can actually go back. I'm not sure if it matters. Nope. It's 8. 2 to the power of 8. So you're saying that there are 8 elements to be found? Even though I found only 6? Maybe I need to double check. Trying to remove a little arrow here that didn't go well. So here we're going actually here and finding a mug. Once we reach the mug, we are, let's go to get to the mug. Up, right, right, up, right. No, where am I now? I can't find where I am. Okay, let's rerun. So you found only 7. Oh, okay. And you still made it, so the 7th item was not important. Okay, so we're at the checkpoint right now, and we go right, and we go up, and we go... We can go only east and south. Yes, we go right. We can go north, east and west. There is on the east, which means right. There's nothing there. Let me write that down. Nothing there to pick up. So we go again to the left and up. There's an escape pod and we cannot take it. We go to the right. There used to be a mug there, I think. Oh wait, we can still go right. Ah, but then there's nothing. Okay, so here was actually another place, but we cannot go anywhere from there. So we go east, which means left, and then we can go left. Oh, did we actually pick up the mug? I think that I might have misunderstood something. Maybe I didn't pick up the mug. Maybe the mug was all the way on the right here. But if I didn't pick up the mug, that means that the mug should be there still. You take the mug, okay. So we actually did take the mug. So now we're at the escape pod and we can go north, south and east. Right. So let's draw... Ah, here I drew the mug. Just right here. Okay. That's fine. This is another way to draw it. So, escape pod. Then we go up and we can go... Oh, at the mutex. Should I pick up the mutex? Take mutex. I take the mutex. Okay. So now we have a few more items. So that means I need to pick up the mutex just before picking up the ice cream. Take ice cream. So before going to take the ice cream, I take the mutex. For some reason I'm only taking foods, but I'm not entirely sure. Oh, you should make a screenshot of your 50 screen with the moving background. So don't click through it when you get there. Not sure what you mean. So you made a kind of screenshot of all your steps through this? Okay, so we now have the mutex also. And maybe there's something else. Let's, maybe the photons. Maybe I should just take the photons. Seriously? I should take the photons? I guess so. So south, after going, when we start, we actually wanna, so we are here taking the piece, and then we are back on the start, and we're going south, and then we take the photons. Yeah. So we've now added the mutex, which I'll use a small m for, and we have the photons, which is p with a small letter p. So there we are. We need to know all of the location, all of the combinations. So we have our items, which is this, right? And then for each of the combinations, for each of the items, we're going to create combinations. For L in range 0 till the length of the number of items we have, we're going to do something. So let's make a list of combinations, which is empty. And then for each different kind of length, but let's start at length 1, and let's not take all of the items for sure. We're going to figure out the combinations of all of the items, items keys, yes, with that particular length, and add it to our list of combinations that we can do like this. Now our combinations looks like this. It's a very, very long list, I hope. And this code I'm going to use actually inside my program, so I don't have to rerun that. Bit of logic. Like that. You think so? You don't think you can get that screen again? There's some kind of screen with suddenly the sun starts getting a lot closer. Okay. You can click the link you clicked before. What kind of link are we talking about? Was some link posted that I didn't see? Or maybe there's a link output by the program. Okay. Let's see that when we run it. So import iter tools as it. Oops, like this. And combinations, we don't need it anymore, we're generating it on the fly. Now let's run it and see. Hey! Ah yeah, I'm eaten. Oh, I shouldn't take the photons. I shouldn't take the photons. That's right. I'm eaten by a gruel. So now it should still work, right? And we have now 7 items. And when we finally pass this super sensitive floor, do we like finish right away, or do we still have to explore? That's something that is not clear. Oh, yeah. You may proceed. Oh. And then what? Santa notices your small droid and looks puzzled for a moment, realizes what happens, and radios your ship directly. Oh, hello, you should be able to get in by typing this one at the keypad. Okay. So we actually found the answer. Nice. Day 25. Last day. And it is right. Yeah. Cool. So how many combinations did we actually find? Let's look at the length of combinations. 246 if you also take single items. Yay! Okay. That was cool. That was very, very cool. So it's nice that it actually stops when you're done, instead of just saying, okay, you're in, and then we need to find something else, because then we would have had to really search through all of the combinations to see where it worked. So let me commit this and see what day 2 is about, part 2 is about. So that is day 25, part 1. Commit. And thank you for iter tools with combinations. That is helpful. Now let's go to part 2. And I'm gonna put this, make this big again as it used to be. Yeah, Eric thought through all of this very carefully. I know that. I know, and it's also been tested with quite a lot of participants. Oh no, I need 49 no. Oh no. Do I don't have enough stars to align the warp drive. I need 4 more. No way. Okay. Part 2 is your Christmas present, a free star. Okay, let's see. As you move through the main airlock, the air inside the ship is already heating up to reasonable levels. Santa explains that he didn't notice you coming because he was just taking a quick nap. The ship wasn't frozen, he just had the thermostat set to North Pole. Okay, you make it. Okay, you know what? If I need 49 stars, I can totally do that because I have day 18. I know I can solve it, but that would just give me 2 more stars, and I am missing actually the second part of 2 other puzzles as well, so I can get to 48. It will still take some time, but to get to 49 I probably need some help. It is the one with the card shuffling, and the other one is the one with FFT. Both of them are kind of similar in what kind of skills you need, and I haven't been able to figure it out, although I think for the FFT I do kind of know the main points, and then maybe I can figure it out. But I think probably day 18 is my biggest chance so far, because I have to do still part 1, and once I solve that I can probably also do part 2. So 59 stars, but the elves told me you need 49, but the elves told me you need 50. Santa just smiles and nods his head toward the window. There in the distance you can see the center of the solar system, the sun. The navigation console beeps again. You don't have enough stars to align the warp drive though, you need 4 more. Okay. Do you want to do it now, or do you want to stream those for another day? No, I do want to do it now, it's still kind of early. So I can do that. So, that means it is, for now, end of day 25, part 2, because I have not enough stars. So I'm going to go to day 18 and remove a whole bunch of code and replace it with something more correct, more decent. So let's go back to day 18. Yeah, you can see here which ones I'm missing. That's not too many. So what I've made so far is actually calculating all of the dependencies for the keys. So to remind you and to remind myself also, let me show you what the matter is with day 18. On a full screen whiteboard this time. So we have an amazing grid with, well, actually it's not so much of a grid. Well, it is a grid, but there are walls on the grid. Just very roughly speaking, those walls might be anywhere, like this. Okay, so those are walls on the grid. I'm not sure if it is clear enough. Maybe it's not clear enough. And we are some kind of person, and we have doors on the map. Those you cannot go everywhere like this, but there are also keys, and the keys are spread out throughout the maze, and our goal is to find all of the keys. As soon as you touch a key, the door is opened, but every key belongs to a specific door. So let me zoom in a tiny bit. So let's say we have key A here, and we have door A here. And the keys are noted with small letters like A, and the doors with big letters A. And the doors are actually on an entire tile. So basically, you can consider the whole square to be a door. That is a small detail, but important. And that's it, basically. That's it in a nutshell, except that the maze is quite big and there are 26 keys, like that. And that means that there are a lot of combinations. And yeah, you can of course walk and see, oh, and maybe if I do this and then I find a key, then what can I do next? Go back maybe. You can do it step by step, but I thought that was a bit slow. So what I did is I actually create kind of highways. You might think of them as highways from key to key. So let's say that we have key A and B. So here's B and here's key C and D. So I kind of created jumps from A to D, but of course those connections, they go through the actual maze. So like this, you know, and from D till B. In this particular maze, I'm not sure what the shortest path would be. Maybe here. So I'm just ignoring the doors for now, right? And from D till C, it's like this, and from C till A, we can go here and all the way up and left. And we have still a few left from A to B, and from, I think that's all. Okay, so I've already created all of those paths, and I call them, let's see how I call them. Shortest path, no. Let's see. Key paths, that is what I call them. Or actually, no, that is not exactly what I'm doing. No, I didn't do that. I didn't do that at all. But what I did do is whenever I try to go from one place to the next, then I'm storing those paths in a cache. So I have a cache that contains, oops, that is a bit different, cache that contains all of the paths. So that when I decide from going from A to B, that I don't have to recalculate it every time that this is an option that I want to evaluate. And also I pre-calculate the paths to all of the keys from the starting position. And why do I do that? Because I want to know which keys you need to go to those particular other keys, or actually which doors you'll pass. So from the starting position, to go to A, for example, we would go like this, and we are passing a particular door here, and that door, let's say that it is B, and let's say this door is door D, and this, we should have another door somewhere, like here, for example, and this door would be then C. So I now found out that to go to key A, we are going to pass door B, right? And that means that you first need to open door B before going to A. And now in the maze I just drew right here, that doesn't make sense because you can just kind of go around, like go here and go up. But, oh, geez, my whiteboard is actually not showing. Was it not showing the whole time? Jeez. Oh well. So what I was explaining, I have no way to check whether or not it was showing. Maybe anyone can comment. I'll just go and revert a lot of things that I was just drawing. Like this. It was showing for most of it, okay. Then I guess I just accidentally touched something that made it not show anymore. So what I was saying is that in the case of this particular maze, you could just go down and just go around the door to reach A. But in the actual maze, in the puzzle, there's only one way to reach every key. And I haven't formally verified this, but when you look at the maze, that is kind of how it looks. So basically the shortest path to any of the keys will pass through some dependencies. And in the case of A, that is B only. And actually in my puzzle right now, I think that all of the keys have only one other dependencies. So let's see if that is true. So if we want to go to C, well, let's say that to go to C, okay, this is actually impossible because you need C to get to C. But well, this way works, right? So C has no dependencies, like this, nothing. And to go to B, we can go like this, for example. So B will have a dependency on A. And then what else? A D has a dependency on something. Let's see. Well, D, well, that is actually impossible. So let's go through C to get it. Yeah, let's imagine that that is the right way to do it. So now, a simple algorithm would be to first start with all of the keys that have no dependencies, which is in this case only C. And then, so that is the first option to try from the start. So we'll try first by C, and then after we've gotten the C key, that means that all of the other keys that depend on C are now going to be available. And hold on a second, I see that I said that to reach key D that you need key D as well. That was incorrect. I wrote it wrong. That should have been C. So after getting key C, that means that now D doesn't have dependencies anymore. So we're kind of scratching that one out. And now we have an option to visit D. Do we have any other options? Can we visit A, for example? No, because A still has a dependency on B. And C was already taken. So C is also taken out. And so that D is our only option. And that is kind of how I decide which options we have. And now in the real puzzle, there are so many keys, and you can actually get multiple keys at every stage. It's not super linear, like you have to always get one particular key to go to the next one. So that means that, yeah, how can I explain that? What it means is that there are many different ways to get a certain key. Would you like a slightly different perspective on how to model things, or would you like to figure it out by yourself? And yeah, the puzzle is designed in that way that there are no loops in the maze. Mistakes were made. Thank you for your suggestion of a different perspective. I think I will first kind of round up explaining how I was looking at it, and then see if your perspective is going to give me a new insight. So could you hold on to it for a short moment? And then I want to know it. So there's something I realized, and I think it's a nice insight, but I'm not sure if it is the essential one, which is that let's say we try to get key A, then B, and then C, and then in the very end we get, well, okay, let's say we get A and B and then C, right? Now there's also another way to get to key C, and to get all of these keys, which is B, A, and C. So we end up at the position of key C, which is, let me highlight that in green. So we end up here, but now we have first done A and then B. So there are two different ways. There would be like A, B, and then C, for example. But you could also do first A and then B. Well, in this case, those two routes are exactly the same because they're on the same path. But there are some cases where the length of the path is different. So I want to consider that out of these options, that maybe AB was the fastest way to get to point C. So to decide on which paths to explore, I want to make sure that I'm always going for the fastest option, because the order of these keys doesn't matter to reach C, except which one was the fastest one. So I have some check for that, but I think my implementation of breadth first search is just wrong. I'm not keeping my state very cleanly, not in a very easy, understandable way. So I want to kind of re-implement my kind of major pathfinding algorithm, or like a search algorithm, and see if that solves the problem. Now, mistakes were made. You say that you have a slightly different perspective on how to model things. Please do let me know. If you want, I also have Discord, and maybe you can just like explain it verbally. Otherwise, You can also explain it here on the chat if that works. And just in case I'm going to have anyone on Discord, I'm going to open Discord. Takes a bit of time to load. I can keep it in the background. So you bet it would help to go back to day 25 and take the escape pod again. No way. No, I don't think it would help. Because at the end, when you reach the right position, you get the code and the program ends. So we cannot get the code and then get into the escape pod. Yes. So essentially what you're doing is converting things into a graph where the vertices are the keys. Yeah, I was thinking about that, like how can you model this as an actual graph? I wasn't sure about that. So instead of going from position to position, you go from key to key. That is correct. And I think that's basically what I've done in the end. Let's see. And it would be very helpful to convert things into a graph where the vertices are the key cells, the door cells, and the cells where you start. Yeah, so there's one thing about which doors are opened and which are not, etc. Yeah. And the cell where you start. Yeah. So that is the thing that I'm not sure about my state, like what is actually a node in the graph. And not even considering them open or closed. Well, what I do have is a list of keys that I found so far, and I'm using that to determine where I can go, basically. So I think I got it covered, basically. So my messy code right now looks like this. So I have a list of moves, and something that is a bit ugly is that I'm first going to list all of the moves I can do from the starting position, rather than just adding the starting position into the moves list. And I think the problem is I model it as moves instead of states. They should be states, kind of. And so I have a strategy, and that contains a priority. That's something that didn't work very well. I have cost, and I have the found keys so far. I have the length, and I have the position where we are, and the target key. So you see it's all kind of messy. So I'm going to remove all of that, and maybe I'm going to commit it just to kind of not lose this code, even though it's really bad. So git commit. What you're trying to strongly hint at is to think of this as a simple graph problem and use a simple graph algorithm to try to solve it. Okay, I can do that. Day 18, part 1, work in progress. Yeah, I've seen people do that, like first kind of get all the edges of the graph and then just iterate over it. So let's see how that would go. So all of this is going to be gone, and this is gone. And search next key, what does that do? I think it's also old stuff. This is old. I'm kind of doing Dijkstra already, that's true. So here we can start from scratch. So I am first going to re-implement what I did, and if that doesn't bring us anywhere, I'm going to do what you're saying. But I'm making it very complicated with worrying about orders of nodes in the traversals. And pruning things along the way. Simple graph algorithms sort of do that automatically for you. Yeah, but to do that, don't I need to model all of the edges? Like all of the possible edges, which means basically going from every key to every other key in every order. And I thought that would be too much. So that's why I didn't do that actually. So I know that there are dependencies and there are doors on the way, but if there weren't any doors, you would have 26 keys to choose from first, then 25, then 24 and so on. So that would be like 4 with 26 zeros of different edges. And your model is what is reachable from a given vertex, yes. So if you take into account the dependencies, then it should be a lot smaller. But I think I made a calculation, like let's say that on average you will have 4 options for every key to choose, and you would have like 4 times 4, like times 4 times 4 times 4 times 4 times 4, basically 26 times. No, wait, I should do it like 25, maybe 4, and 3 times 2 times 1. But it's still a lot. So let's say you have a path from key A to B that goes through D. Your graph would look like this: A, D, and B. Although you don't need to go through the door really, you just can go from A to B, right? Oh, and G, you actually did generate all of the paths but with some dependency. The program didn't, and even if I had 26 combinations, yeah. So why do I need to go from A to B to D to B? I see, okay. So you're making intermediate stops so that your edges are kind of not different. But I'm not sure if I really see the difference. Okay, I'm gonna keep it in mind. And you're saying the path A, B must go through D in the example you're creating. Yeah, that is true, of course. Yeah, but D is a door, and I'm not sure I need to model the doors, but you're saying don't change the graph. But if you have a door, then how do you make sure that you cannot go from key A to door D, for example, if you don't have the key for door D yet? Yeah, the graph is not fully connected. I know that. Yeah. Okay. Well, I'm gonna try it first without making all the edges, and then see if I know. Yeah, if I can make the edges the way you're saying that I should try it. But for now, I want to start with some states that I want to try, that I want to explore. And my first state is the one where I'm starting somewhere. So I'm at the player position and I have 0 keys. And that is basically all I need, right? I have no keys at all. The reason to model the doors is so that during your search, when you reach a door, you can check if you have the necessary key. If you don't, then you stop the search at the locked door and start backtracking. So you're basically picking all of the doors you could go to, but you do need to check. So when you're evaluating the position, no, that's fine. I don't mind. When you're evaluating the position, so let's say you're popping from your list of states, then you're like looking at a certain door and you see, hey, but I don't have the key for that one. So you're gonna kind of just continue on to the next possibility. Is that what you mean, sort of? Okay. So that's where we start, and these are all of the keys, and maybe we can make a named tuple of that, but maybe not. Maybe we just won't make so many attributes in our state. So while we have some states to check, we're going to pop from the states our current state, which has a position and found keys. States.pop left. Eric, in case you miss me later, it's been really fun watching you solve these this year. You did a great job at explaining things as you go. Thank you very much, Eric. I'm very happy to hear that. And love you so much. Thanks for all of the puzzles and for putting in all of the effort of Advent of Code year by year. This has been a great experience and very much a community building experience as well. And for me personally, this has been the kickstarting of my streaming career. I'm now streaming for the first time, and I'm going to continue doing that, and it's all thanks to Advent of Code. So double hug to you, Eric, and I'm going to kind of keep following you throughout the year and join next year, of course, as well. So have a very Merry Christmas, and love to you all. And Eric Wassel, I hope he will mention later streaming times at the end of this video or on this page. Yes, I will. I am still figuring out what I'm going to do, but in general I am doing a stream tomorrow again, not as long as normal. So tomorrow, that is December 26th at 2400 EST. That is going to be my next stream, and I'll do about 1.5 hours, and we'll review some of the puzzles that we haven't done yet or that we haven't reviewed extensively yet. So those are going to be the most difficult ones, which I finished, for example, offline, or which I didn't finish yet. And your schedule is super weird, so you normally can't watch streams. I know that, yeah. And the graph search generally asks the question of I am at this node, what child nodes can I reach? Then given that set of children, it does its magic to figure out which way to go. If you don't have the needed key, then you tell the search that there are no children of the node, and it has to go somewhere else before going to this node. Yeah, okay. Thank you very much, Mistakes Were Made. I super much appreciate your help. Sometimes I'm asking for help and I don't get any help, so I'm very lucky to actually have a few of you who do kind of point out hints, so that's very nice. And I'm going to do what you're saying in this loop right here. So here I need to check child nodes, right? And also I need to check if I have reached my goal position. But because we have a specific edge cost, so we don't have like a simple breadth first search where every step is the same cost, we do have path costs, so that to see if we found the right answer, let's say that we found a position that works, it doesn't mean that it's the best one, so we also need to keep track of the best solutions so far. The best solution right now is none, and so if our found keys, if the length is exactly 26, then we have a goal, and then we can add it to the best solution if we didn't have one, or if the best solution is actually better. So I also want to keep the total path length so far, so number of steps, step count, up to that position, or the step count is smaller than what was in the best solution. And in the best solution I'm going to create a named tuple for that. That is a named tuple called solution, which has the found keys like this and a step count. I think that's how I do it, right? Keyword arguments, or no, just a list of parameters like this. Maybe a final position also, so that a solution is exactly the same as a state, maybe. So states contains a solution which starts with position is player, found keys is nothing, and step count is 0. Nice. And so if our best solution, can we actually address items from a named tuple with a dot? Yeah, I guess that is the whole point of it, right? So our best solution right now is going to be of type. Can I add a type hint? It is a solution, like this. Yeah, maybe. Does it work? Doesn't seem to really work. Oh, maybe I should use capital S here, and use capital S and here also. Maybe that helps. And then we want to see that our step count is actually, yeah, so our step count is less than the best solution so far. Then our best solution is going to be our solution, which I'm going to keep here. solution like this. That is the current solution. I'm not entirely sure why step count. Oh yeah, it is actually suggested by my editor, so that is fine. And let's print also that we found a solution. Found a solution, and best solution so far is now this one. Okay, and otherwise, well, not otherwise, always we're going to expand. No, if we found a solution, we're not going to expand and try other things because we already have all the keys. So let's see which keys we could try from here. So we are going to generate a new solution for every key that we have available. And to do that, I have to look at all of the keys that we haven't found yet. So let me make that a set of all keys in the keys, which is not in the found keys, right? That is unfound keys. And then we want to have the accessible keys. The accessible keys are all the unfound keys that have no dependencies. So if that key is not in the actual dependencies. No, wait a second. So I have a function here, actual key dependencies, that would check for a specific key which dependencies are known for that key given a certain number of found keys. So how can we do that? Maybe I should just do it inline here to make it a bit more clear. So we have the found keys, then we have the key dependencies. That is maybe we can just go over all of the unfound keys. And why does this not work? End of statement expected. Oh, E key for... Hold on a second. For key in keys, like this. If key not in found keys. That still doesn't seem to work. So maybe I should just make it a list. Key for key in keys, if key not in found keys. Okay, so now it is a set, right? So for all unfound keys, let's check if we can access it actually. So we look up the key dependencies. Key dependencies, that is actually already a variable which I cache. It's right here in a file, and it has all of the key dependencies in general. But for our current case, that is going to be current key dependencies. That is all the keys in the key dependencies for this particular unfound key. If the key is not found yet, so if it is a found key, then it's not a dependency anymore, right? So that is how it looks like here. The current key dependencies are then this one for that particular key. So now, if we have no current key dependencies, then we can actually try to get it. So if we have nothing in the current key dependencies, then we're going to try to find it. So we're going to make a new solution, which is the solution where we have our position, which is going to be the position of that key. I think I call it key pos. Let's see. Oh yeah, the keys actually is a dictionary of key names with then the position as its value. So we have keys, we can put the unfound key there to get the new position. And what else do we need? We need the found keys. So after we went there, we found that particular key. So it's the found keys plus that unfound key. And why is this not okay? Positional argument after keyword, so that means that the found keys will be like that. So far it seems to be kind of very clear how we're working, very structured, and then let's see if it stays structured like this later on as well. 1 second, yeah. Okay, so what is the last parameter? It is the step count. So the step count is basically the step count that we had before, but plus the distance to that new key from where we were. And I have for that get shortest path that starts at our last position and goes to the position of the new key. So let me extract that to not type it all the time. That is the unfound key position. So from there to there, and now I know my shortest path in implementation returns a list of steps, like including the starting position. So to actually get the right length, I need to take the length -1. That is the new step count. And that is it, right? And we're going to append this new solution to the very end of our states. Append solution. So I will call states solutions from now on. Or solutions, yeah, partial solutions basically. They are not full solutions. And that is it. That should be the entire algorithm basically. I'm not very confident that it's going to run very well. And also we get some errors. We are using sets that it doesn't like. So unhashable type set. So unfound keys. That should be a single unfound key, not all of the keys. So here we have now loaded some data and we're trying solutions. And nothing much seems to happen. We're popping. Let's run it with debug mode. Stop all of our code. And so we are trying now a specific solution. And that solution is going to be solution. Oh, I don't see any solution here in the list. Oh yeah, here it is. Let's add that one to the top. So we're starting at 1, 1 and let's actually look at what program we're loading, or which puzzle. We're loading example 4, and example 4 is one of the harder ones. That is, oh no, it's not the most hard one. We're starting here at 1, 1, and then we have a lot of ways to go. And we have key dependencies also. So we have dependencies here. Wait a second, a dependency with only a list of one item. How do we jump to where we were? Here. I think dependencies is something old that I don't need anymore. Yeah, it's just actually from a function, from a loop that just kind of is a leftover after finishing the loop. So we have a solution with found keys is nothing and a position and a step count of 0. And then we'll go over here and we have not found enough keys, so we're going to check the unfound keys. Those are going to be quite a lot of them. And what else? Our best solution is 26. Yeah, and there was something I said before, right? That we also want to check if the solution that we're going to try has not been tried before. So I want to keep track of that in some way. Now I know that basically we're generating different solutions, so they're all unique in the sense that the order of the keys that we're checking is all unique, but some of those might be a bit redundant because we've already found a very quick way to reach key C after getting A and B, for example. So that's something I would still need to do. I'm going to write a to-do for that here so I don't forget. Check if we didn't already reach unfound key with same keys but in less steps. It's a verbose way to say it. So let's run all of the code till there, till we check the first solution. And so we have not reached the solution, and here are the unfound keys. And for each of them we're checking the dependencies. So the key dependencies look like this. So we can reach already A, C, D, and E, and F. Let's look here. We can reach A, C, D, E, and F. That is correct, right? And can we reach anything else? No, the rest does have dependencies. So current key dependencies looks like only C. Well, that is not right, because we can reach A also. So let's see again. We could reach A, C, D, E, and F. And here I'm checking the key dependencies for the unfound key, and that's because right now we're actually only checking whether we can reach key I. And actually that doesn't make a lot of sense. Is that... Hold on, okay. So we're getting all of the dependencies for key I, all the ones for which we don't have keys yet. And for that one we need key C. So here we go. C is needed to go to key I, and that is true. So we're going to skip that one. Then we're checking another key, which is C, and for that we need nothing. So then we can add it to our list. So the position is at 17.1. Let's see if that is correct. We're checking key C, right? Yeah. So that is at position 17. Here 17 characters selected. So that looks right. And then we're making a new solution. And let's see that the number of steps for that, what that would be. I would like to evaluate this code. It's 16 steps from where we are. Let's double check that. So we go 1 right, 2 right, 3 right, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. That is 16 steps. So that's also correct. So that is how many steps. Let me extract that into a variable. Unfound key steps, or maybe next steps, like this. And like that. So these are our new keys, and let's rerun it. And I'll go over first key that we're trying. Oh, now we're trying key C. Okay. So our steps are going to be 16, right? Yes. And we're adding it. Gee, you're taking a break? You woke up too early? Yeah, we all wake up early these days. So have a great rest and enjoy your Christmas so much. And maybe see you tomorrow again or in one of the other days. I'm going to stream also on Saturday, and most likely I am going to do that during daytime in Europe. So that would be, let's say, around noonish. I'm not entirely sure. Maybe noon. I'll post it on my channel so that everyone who is following will know about that. So, goodbye. So we're appending now this new solution. But that is actually not the new solution. We should create a new one and append that one. Oh, not the original solution. I think that's where it went wrong. So we've now run everything and we've finished. That means we've tried everything and couldn't reach a solution. And that is because in this example, We don't have 26 keys, but we have something different, so let's not hard code that. And we're trying to print our best solution here. We need a tuple for that. We found a solution, but only the first one is actually the best one, it looks like that. Let's not print every time we find a solution. Or maybe we should, and just print all of the found keys. Like this. So we're finding a lot of solutions, and they all start with F maybe, or maybe not. The best solution here is 83 steps. And I think the answer should be 81 steps. There's something not entirely right about it. And so in the example, that is this one, the best is 81 steps. Hey Alex, good morning. Oh yeah, you were not there this morning. And I see you also haven't worked on the puzzle, so I guess you had a nice sleep in after Christmas Eve yesterday. So with my previous implementation, I also got 83 for this particular puzzle. And the answer that is provided here is quite different from my answer here. And do I actually evaluate the possibility where you go from A to C and so on? Let me check that by imploding all of my keys with commas. Join like this, and then seeing if we find that solution in our options. And we did, but how many steps does that take according to our algorithm? According to our algorithm, that takes, let's see, 81 steps. Oh, okay. So that means that actually we do have the best solution, but we don't actually add it. And so if we don't have a best solution, or the step count is smaller than the best step count so far, then we're going to say best solution. But why is our best solution here 107 and then less and less? Oh, actually it works. It's just that we shouldn't look at the last output. We should kind of in the end just print the best solution. So let's call it print solution like that. This puzzle looks like it's another manual one, or are you coding it at all? Well, yes, that's a good question. I did do it manually until I realized that there's some part of it that requires you to try out a lot of different options, and I actually coded something to do that, but other people have solved it completely manually, and they say if you think about it good enough, then you know that there's a way to do it without trying every possible combination. So it's up to you. You can do it by hand. I did it with some algorithm. But yeah, implementing the algorithm also took quite a bit of time. So a solution will be printed like this. Like this, with the steps. Print solution, solution. And then we'll say best solution also. And print it. Or maybe just like this. Yeah. And then in the end we'll print the best solution. Right? So I think we actually have an implementation now. But why did I not see the best solution? Oh, I'm not actually passing it. I should first explode, or I should just do like found keys and then solution.step count like that. And the best one is the last one. So I am more confident now that my code is correct. There are less than 300 possible solutions and there is a way to prune it. I got it manually on my 8th try. Whoa. Hey Shaburu X, how are you doing? Hello to you too. Are you also doing Advent of Code, and how was day 25 for you, the final day? And more importantly, did you also get part 2 right? Because I am not able to do part 2. Merry Chrysler. That would be great. A Chrysler on Christmas. I am good. I'm very good. I just re-implemented day 18, or part of it. I'm working on Advent of Code day 18 because I am a little bit behind. So you might not know Advent of Code. That is a Christmas style puzzle event that releases a new puzzle every day from December 1st till the start of Christmas, which is today. So we're at the last day of it. And it's a programming puzzle. So we get some kind of algorithmic challenge or some kind of game. And in this particular game, we have a maze and it looks like this. So hashes are walls and dots are empty spots. And in the maze are doors indicated. Let me zoom in just a bit. And doors are indicated by capitals. And the doors have keys that are here, the lower letters. So how do you reach all of the keys? It is, in this example, to get key E, for example, and then E is opened. And then you go back and get D, and then go back and open door D and go to F. So now, let's say that your puzzle doesn't look like that, but it looks like this huge thing with 26 keys. How do you get all of the keys in the least number of steps? That is the challenge for day 18. And to solve day 25, actually you do need to get 48 stars, which means that you have to solve 24 puzzles, both parts, to be able to do that. And or actually, maybe you need to solve 49, which means basically every puzzle. Okay, so you need to solve every other puzzle before you get the last star. So people will have either 48 stars or 50, and no one will ever have 49 stars, basically. So I just re-implemented my search algorithm, and now it is actually able to find the shortest solution to example 4, and example 3 was one that is a bit harder. That is, I called it example X because I forgot which number it was. So let's try example X and run that. And I remember that it took too long to figure it out because there were just too many calculations, too many options. But we can prune a few of the options. And now at this point I would like to see how many options are on our list. Maybe we can print that every time. Print the number of solutions that we have. And let's calculate the length. Partial solutions. So that we get some idea of what we're dealing with here. So you can see that it's expanding very, very heavily. And that's not a good sign. So already 500,000 new branches are arriving. So now I want to kind of keep track of good solutions, or kind of a list of partial solutions. So basically if I found key A, B, C and D, that means we ended up with D, then I want to know for sure that to end up with D with the other keys in your pocket, what the best solution is for that. Best partial solutions. That is going to be a dictionary. And so when we try out something, like here, a new solution, then we're going to store it in the best partial solutions so far. And for that we are going to keep a certain key, which has all of the found keys so far as a set. And I think sets are not hashable. I'm not sure. Are sets hashable? Let me try. So we have a dictionary called A, like this, and we're going to address a set with 1, 2, and 3 in it, and say that that one is 42. unhashable type set. Okay, so we have to make a tuple first. So we'll make a tuple with two parts, with first the found keys. So that is a ordered list of found keys. Is it ordered or sorted? Sorted. And let's turn that into a tuple. And also the next key that we're going to find, so the unfound key. Because the last key is the key where we're going to end, so that is important. And we're going to keep there the next number of steps. But not only the next number of steps, but the total steps. Unfound key steps, like that. That is what we're going to save. And why do we get unexpected argument? That is because I closed... Wait, I have a tuple here with a tuple in it and then another value. Okay, I can do it without the word tuple, of course. Maybe that's what I should do. Yeah. Okay. And I want to only do this key if it wasn't already checked before with a better solution. And here I'm checking if we can actually visit it. So that is the right place to check if it was already found. So let's extract the kind of index that we're using for that particular solution. Partial solution label maybe, or class or group. Yeah, partial solution group. So if that group is already in the best partial solutions. No, wait, we can actually try it if it is not in the best partial solutions, or if it is and it is actually better. So our next steps, no, our unfound key steps is actually less than the best partial solutions with that particular group. And then the second item of that, no, the value of that, that's all. Okay, so then we're going to add it and we're going to append it to our partial solutions that we're going to check. Let's see now if we get a little bit less options every time. And we do get an unhashable type list. So here I should make this into a list or a tuple. Yeah, okay, I do need the tuple keyword to convert my list into a tuple. So now we see that we have around 33,000 solutions on our to check list instead of hundreds of thousands, and we do get the best solution of 136 steps. So that is basically it, and now I feel like it's probably going to work also on our grand maze. And unfortunately I don't have a visualization now because I'm not keeping track of the entire path, but we could technically render one by taking all of the keys and basically making a list of how to go from key to key and then print it. That would be kind of cool. But I'm going now for a blind solution, and I'm not gonna print all of the solutions that we have left every time. Maybe only when we have done 100 iterations or something. Like let's start at 0, and then if I plus... Can we do I plus equals 1 and get a result from that? No, we can't. So at the end of our loop, we're going to increment I, and if I is a multiple of 100, then we're going to print how many solutions we have left. And it did print quite a lot of things, maybe. Yeah, now we get a little bit less output. Let's also print how many we've done, just for fun and information. So how many iterations do we actually do to get this solved? That is about 150,000 or so. Okay, now the actual input. Input.txt, let's go. So at first we are going to calculate a lot of paths, but then at some point we're going to have them cached, like all of them are cached, and it's going to be a lot faster. And as we break through to a better solution, then we're also going to have to calculate more paths, but that is normal. And we don't know at this point how many keys we've found already, so we don't have an idea of progress. But I'm kind of confident that this is going to work. 100,000 solutions on our checking list. That is not too crazy. If it would just ever grow ever and ever more, that would be a problem. So 50,000 solutions left, 30,000 left, so it's really narrowing down, and we found the best solution with 4,204 steps. Well, I'm kind of confident that this is going to work. What do you think? Let's go. Yes, it's right. Wow. Wow. Okay, so conclusion is that basically I should re-implement my code in a more clean way when I'm getting stuck. Podgers, thank you for Podgers. I'm not sure what Podgers means, but I'm very happy to solve this. And also, well, because I've already thought about it so much, I kind of knew what I was gonna do. But you see how I implemented it kind of from the start till the end, although I did have a lot of ingredients ready or beforehand. But I like that. Just going step by step and don't make any mistakes. But that is only possible if you really get it. You have it very much in your head and know what you're going to do, and also are confident that it's going to work. So it's a bit long. I want to break this up a little bit before committing. You heard the star. Oh, right, cool. So the stars actually do playback on the stream, but I just don't hear them myself. So maybe that means that I need to monitor my stars. Yes, I do. Let me check that. I have my alerts, and I do specify that I need to monitor it. And my sound output is correct. Okay. I'm not sure exactly what works. Podgers is from the Urban Dictionary, a Twitch emote that may only be seen if you have better TTV installed. It is used in place of this face as an expression of extreme excitement or hype. Okay, I don't have better GTV installed. Is that something I need to install on my stream, or is that what I need to install on my client? So do I need to make a bot for that? So I don't have a bot right now. Maybe it's something I should look into. Git commit. You know what's interesting about the 18th puzzle is that I thought I needed to do a star, but apparently you don't. So if you do your breadth first search correctly, you don't really need a star, at least right now. I was so obsessed with a star trying to find good heuristics and sorting my queue, but in the end I was adding way too many other branches. Yeah. So now actually I did solve it without applying the suggestion by mistakes were made. Mistakes, are you still here? Like, do you feel at this point, now that I found a solution, that what you suggested is fundamentally different, or is it basically the same, but I am not doing two phases, or is what I made kind of what you meant? And by the way, I think that the partial solution group that I came up with is very important. It is really crucial in finding the right answer. But I wonder, did other people also solve it that way? Like, did you keep track of all the keys that you found so far, but discard the order except for the last key? Is that what you did? Because that is really, I think, the lifesaver here. And better Twitch TV is an add-on for the browser. So it's not okay, so it's I don't have to put it on my stream to make it work. Okay. Yeah. All right. So that was part 1, and how about part 2? I cough away from the mic so you don't hear me cough. Part 2. You arrive at the vault only to discover that there is not 1 vault, but 4, each with its own entrance. On the map, find the area in the middle that looks like this. Update your map to instead use the correct data. Oh. So you will split your map into 4 separate sections. Because some of the keys are for doors in the other vaults, it would take much too long to collect all the keys by yourself. Instead, you deploy 4 remote control droids. Each starts at one of the entrances, yes. Your goal is still to collect all of the keys in the fewest steps, but now each robot has its own position and can move independently. You can only remotely control a single robot at a time. Collecting a key instantly unlocks any corresponding doors, regardless of the vault in which the key or door is found. Okay. For example, in the map above. Ah yeah, okay, I see. So we're kind of moving around the robot on the bottom left, for example, and it would unlock C, but then robot A, who is on the top left, can move again and try something else. Okay. Maybe that's not too complicated. It just means that all of our states are going to have 4 robot positions instead of 1, right? That's the only difference. Yeah, that's not too hard to expand on. And we have a small example that we can use to try it out. Maybe we should try that out. But I was collecting the players' positions and I was calculating all of the key dependencies for starting from the start position, and so that's not going to work exactly anymore. Although the dependencies are still kind of the same, right? I think, because let's have a look. So we have a grid with 4 quadrants. And in each we have a robot. Like this. Let me make that middle quadrant line a bit thicker. Let's make that nice and thick. Okay. So our robots are here, 1, 2, 3, and 4. And now let's say that there is a door D here, or well A, that we need to open to get to another key, but the key for A is actually here. So now when robot 2 is going to A, then 1 can actually go to A. So the number of found keys that we have is still kind of shared globally. So what is the difference? The difference is only that we can move different robots at a time. But we have 4 robot positions and that's all. So all of the key dependencies that I'm calculating are still correct, I think. Except, yeah, I think it's still correct. Because originally I calculated the key dependencies by going from the center to a particular key, like here. And since all of the doors and keys can be reached from the center, then our dependencies are still kind of correct. And that's why that maze started out with an open space in the middle. Just give me 1 second while I turn on the heater here. Okay, so I'm back and hopefully it will heat up here a little bit. So for some strange reason it is less cold in the living room at 5 and 6 AM than at 9. I'm not sure why. Maybe because heaters are off everywhere and the apartment building is actually cooling down in its the whole apartment building. Alright, so keys are shared. Keys shared, and then we need to make 4 positions, and that's it. And I would like to extract the positions from the map, or maybe I don't care about 4 positions. So let's copy all of this into a little function for part 1, like this. And we start with partial solutions like this. That is fine. I'm going to copy that. Hey, I love BBW girls. I'm gonna go into what that might mean. Good morning or good evening. Merry Christmas to you. So part 1, that was this part. And now I'm going to make a part 2 that is pretty much the same. And I hope to be able to solve this in no more than just a few minutes. I'm very confident. So a solution for part 2 actually looks a bit different. And what am I making? Well, I am participating in Advent of Code, which is a puzzle event. And between day 1 and day 25 of December, we get a puzzle, a programming puzzle. And our puzzle today is to find all of the keys in a maze, and every key opens a door in the maze, which is indicated by a capital letter, and the keys are small letters. And we just solved part 1, where we have one robot and it goes around the whole maze trying to find the best solution. And here you can see I found a solution and which order you need to take all the keys and how many steps that takes. And for part 2, the maze is actually suddenly divided into 4 parts. So you can see that in the input for day 18. It's not super clear to read, maybe. Maybe if I highlight all of the hashes. Well, it is very painful on my eyes. But you can see here in the middle that we have a horizontal separator and vertically also. And so this is going to be completely divided, and we're going to have 4 robots, like here, 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 and here. And then we're going to have to let all those robots search all the keys independently of each other. And that is where I am now. So I need a new definition of what a solution looks like. So we have a named tuple called solution2. Solution2. Mining. And that is going to contain same variables, but it is going to have 4 positions instead of 1. So maybe I'll make that into a list of positions. Yes. And what else do we need to do? We have partial solutions where all of the robots are around where we started. So that means player, the center is basically the player. So that is center X and center Y. So the first robot starts at Cx minus 1 and Cy minus 1. That is going to be a tuple. And also Cx plus 1 and Cy minus 1, Cx plus 1 and Cy plus 1. Those are all the 4 corners. We have no found keys. And here we have a best solution, which is of type solution 2. Here we go. And that's that. And when we extract, we have the positions. And what else? We need to update our grid. And to update our grid, we are going to actually copy the input file. Maybe. Should we? No, maybe not. Let's copy the no, let's not copy the input. So I'm still working with the maze, I think, when I'm doing a shortest path, for example. Shortest path. Here it's using the which one is it using? It's using grid. So we have grid which is a kind of which is a dictionary with tuples as keys. So for part 2 we're going to override the grid, part 2, and how we're going to do that, it's just like this. So the grid at center position -1 on the left, that is going to be a hash, and on the right is going to be a hash, and above is going to be a hash, and below. And now what else? We can run the rest pretty much the same, except that we need to consider all of the positions and not just one. So for each of the robot we can decide to move somewhere, and that looks like this. So we have all the unfound keys and we have the dependencies, and if we found a key that has no dependencies then we're going to add it, but which robot is gonna go there? That is the question. We can decide based on which quadrant the key is in. I guess that is what we can do. So the unfound key is here in this position. So let's decide on which robot first. Which robot? So if the unfound key position, the X position, is on the left end, so that means on left of the center, and the unfound key position is on the top, is higher than center Y, then we're going to do the top left robot, and that is robot 0, I suppose. Let's see what I did. So we have top left, top right. Oh, I have only 2 of them. I want to do them bottom left and then bottom right. Okay. And what else? If we are the top right, which means bigger than the center and smaller than the center vertically, the robot is the first one. And then another case where we are on the left but we are lower than the center, then it's the third robot, and else it is the robot with index 3, which is the fourth robot. And then our position is going to be, out of all of the positions, the one with the robot, and that's it. So the new position is we're going to use solution 2, and the robot position is that one. Maybe for the next okay, thinking about a variable name for this position, it is the assigned robot position. This is the assigned robot, like this. And so we're going to find the shortest path from the assigned robot position to the unfound key position, and our new positions is going to be new robot positions is going to be the old one, but we're going to replace the assigned robot with the assigned robot position, but also it should be replaced with the key position. That is where we're gonna go, right? So the unfound key is going to be a found key, and we're adding the steps also. That is it actually. And how about this? There's a continuation missing. That is fine, I don't really care. This might be on the same line, no problem. I think that is it. And then the best solution will contain our best solution has now a little bit of a different definition. So we are keeping a list of partial solutions, and that should now not only contain the found keys and which one was the last key. No, it should now contain all of the found keys and the position that we are in. So the next found keys, and that is something I didn't realize before. Instead of sorting all of the found keys so far except for the last one, we could have also sorted all of the keys and then specify where we ended up. That's another way to do it. So we have the next found keys, that is what we're sorting, and then this is all of the robot's positions, and those are going to be, oh, I'm referencing the wrong variable here. New robot positions, those are all the positions, and then we're going to add to that group unfound key steps. Yes, and we're appending it. So that is it. Let's run part 2, and maybe that would work. And here we have an unhashable type list because I'm making a tuple with some positions, and that should be casted into a tuple. And now we get, of course, a lot of output, and we're trying a whole bunch of things. And I have no idea if what it's doing is actually correct. So let's let this run for a while and see if we get an output. It hasn't found any solution yet. Do I print when I find a solution? Yes, I do. And printing the solution would do like found keys and step count, and I'm not checking the robot's positions. I guess that doesn't matter also. So now we have around 150,000 solutions left, so that's quite a bit more than before, I think. I'm not sure if we should get less solutions or more, because we still have a lot of options. So what we're doing, right, just to kind of recap, we're checking for all the keys we haven't found yet and that are still accessible. And so let's say it's A, then we're going to use robot A to move. And before we always had the same person to move, so it means that there are not really more options than before. It's not like we can suddenly try to go with robot 4 to go to A. That is really not different at all. So I think that probably the calculation time is going to be roughly the same. And you see that the number of solutions are shrinking. So that's a good sign. We have evaluated 1.2 million options and we're finished. Cool. I hope that works. Let's see. 389 steps. It's not the right answer. The answer is too low. Make sure you're using the full input data, and there are also some general tips. Yeah. So there's something wrong, and maybe that is because... Why is that? Am I adding enough walls everywhere? I didn't add a wall right in the middle. I'm not sure if I should. Maybe it's because of my cache that is giving me problems. We could try it out on this example here. Like this. Well, I'm going to make an example for part 2. Example 2a. Let's make it a text file. Like that. And we still have the center in the same way as before, so that's handy. So we can use the same logic basically. And now I would like to run it and see what happens. Key error E. Why is that? We don't have a key E. But why do we think we do have one? because I'm actually running a piece of code just to check my dependencies, and it found 8 steps as a solution. And in the solution we go first selecting A, and then B, and C, and then D. Okay, and that is 8 steps. So our step calculation is correct. It looks fine. Maybe I'll add also a hash in the middle. Let's do that. Like at CX, and also maybe I should not use any caching, because I think I have a cache here where I'm checking the key paths. Maybe I won't do that. So the key paths, that means that we have a path from the center to every key, and that checks for the dependencies. And I think we can keep that exactly the same as it is. Yeah, so I'm not sure why my solution was not right. We said that our answer is too low, so we need a little bit more steps than what we found out. And so 398 was too low. I'm not sure why. I guess as long as we don't see the maze working, it is hard to tell if it is actually working or not. So let's print the maze. So every time we find a solution, I guess, or every time we do a step, let's print the maze. So here, maybe every now and then we print a maze. So to print the maze, we'll actually calculate the entire path. So that is basically a matter of going through all the found keys, from the first till the second, and from the second till the third. So to get that, you can basically zip your found keys and then zip them with the next item. So that is from 1 till the end. So for pairs in this list, then we're going to find the shortest path between each of them, and they are cached, so we don't have to worry about performance here. Key A, key B. Find the shortest path between A and B. Key B. But I realize now I should pass in the positions and not the keys themselves. So, like, wait a second, like this. I pass in keys A and keys with B. That is the path. And then I want to make a giant path, solution path, like this. It's an empty list. I'm going to extend that path every time. Extend with that one. So some of those items in the paths are going to be double, which is not a problem, because I have a print maze function here that shows a position, but only one. So I cannot actually show where all of the robots are. That is a bit of a problem. So I'll just keep center X and center Y as its position. And then I'll show the solution path, and we'll print it, and we'll clear the screen by using os.system clear. And let's see if that works. We input, or maybe I'll print it, I'll clear it before actually printing, so we see something. And we'll sleep a bit as well. Let's sleep a half second using time.sleep. Now we need to run it using an emulator rather than just a normal Python console. And now we can see the output. Oh, hold on a second. We have a problem here. Non-type is not iterable. So some paths are actually impossible. That is interesting. Yeah, and that is because we don't necessarily go from the last key to the next key. We actually go from where the robot was where that particular robot that took the key was to the next key. So basically we cannot actually render the path. We don't have enough information. We don't remember which robot went where. So how can we solve that? I guess we cannot solve that. I could just print the maze with only the found keys as kind of a path, so we would highlight only the found keys. Maybe I'll do that. So that is a position for maybe the keys, key or key in found keys. That is the best I can do so far. So now you would see, oh yeah, and I remember that if a key is found, I'm actually I'm not printing the path on the top of the keys. So we do see that we split up the quadrants correctly. And maybe we can just render a random robot. No, we also cannot do that. Okay. So that means I'm really not sure how I'm going to solve it. I think for now, for today, I see that it's getting a bit quiet on the chat as well. So I guess a lot of you are doing something else in the meantime. I'm going to try to solve this puzzle later. I know I've already postponed solving day 18 a lot, but I think it is time to have a quiet Christmas morning without streaming. So I'll end the stream in a moment. And so what is my plan for the next few days and weeks? It is first of all to start with tomorrow doing a review of some of the more tricky puzzles and maybe day 18 as well. So do come online at the same time as usual, which is 12 p.m. EST, which is New York time, and that is equivalent to 6 a.m. Brussels time. And so we'll review some of the puzzles. If you want to share some code, do get your code ready to be shared. I don't mind if it's a bit messy or not clean, but if you want to clean it up, you can, and you can do that in advance. So tomorrow morning I'll ask for you, do you have any code to share, and then let's have a look. And one of the puzzles we'll look at is day 22. And then on Saturday, and I still have to decide on a time, but for now let's say that Saturday would be 12 noon in Brussels time. And I'm not sure what that will be in New York. I guess it's going to be 6 hours earlier, so that would be 6 a.m. EST. And what we're going to do is I'm going to introduce to you my plan for the stream for the next few months. And that is going to be that we're building a personal assistant AI together on the stream. It's going to be a modular AI in such a way that everyone can build their own module. So you can build your module that helps people with scheduling, a module that helps people warning about the weather, or a module that helps you to keep track of some information like your company's tax number, for example, which I always have to look up in PDFs. Or anything else that you would actually have expected from something like Alexa or Google Assistant. I find Google Assistant and Alexa so frustrating, or Siri. Ask them anything simple and they don't know. Ask Google where you live and I don't think they know it. Or ask Alexa what your tax number is and they don't know. They don't even know which languages you speak. And I think it should be not that hard to implement a basic personal assistant that takes different kinds of data input and kind of gathers all of that. And so the full introduction will happen on Saturday. Let me decide right now that it's going to be 12 at noontime, Brussels time. So do come on for that event, and otherwise we'll see each other tomorrow.